Hello, Calculus 8.3. This is mainly an algebra lesson. There's a little bit of integrals in it, but it's more algebra than anything. So it's an interesting algebra idea because what you've done, you spent a lot of your life taking fractions, trying to add them, making a common denominator, coming up with a top. You've spent a lot of time working in that direction. What they're going to do to us today is the algebra equivalent of going back the other way and figuring out if 12 was the common denominator, maybe 3 and 4 were the original denominators, and they could figure out what the tops used to be. What adding problem could create this? It works better with algebra than it does with numbers, because with 12s, we could have had 3 and 4, or 3, or like 1s and 12s, or there'd be different ways those could have been to force you into the 12. But with algebra, it goes a little bit just cleaner. So what we're going to look to do on any problem that you have, if the bottom can be factored, look to factor the bottom. Okay, so I have a top, here I have a bottom that I already factored. If this is going to be our answer from adding two fractions, chances are x plus 1 had to be the bottom of one of them, and x minus 3 had to be the bottom of the other. That's how this turned out to be the denominator after we added them. So we're going to take these two denominators and put 1 in each fraction. The top is a mystery to us for now, so I'll call this A, and I'll call this B. And what we're trying to do is figure out what's the A and what's the B. The best way to do this is to multiply this whole problem by that common denominator. Because if we multiply by the common denominator, this will bump this off, leaving the top. This will bump off this. But the A would still have to multiply the other piece. This would get bumped off by this, but the x plus 1 would multiply the B. And we get something that looks like that. Distribute. And then use the variables to spot some like terms. 5 has an x. After the equals, the A has an x. The adding B has an x. So these three form a family because they all had x's. The 5 would have to equal an A plus a B. The negative 3 would have to equal the other stuff. A negative 3A plus a B. Now we have an Algebra 2 flashback. This is called a system of equations. You have two variables, and you have two equations, and there's a lot of ways that you can solve these. The best way is usually try to work through a thing called the addition method. With the addition method, ideally we have some opposites that we could just add the equations together and one of the variables disappear. This doesn't quite have that, but it is fixable. If we wanted to bump off these A's, I could write a 3 here by multiplying through the whole problem by 3's. If I multiplied everything in this problem by 3's, I'd be able to add those together and the A's would vanish and I'd be all right. I think it's easier to go after the B's, because to go after the B's, I just need a switch of sign to make my opposites. So I'm going to switch, 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 and add these together. 8 would equal 4A, with those disappearing. So A would be 2. And if A is 2, 2 is adding B to make a total of 5. If the A is a 2, the B has to be a 3. So I go back up here, I make the A a 2, I make the B a 3. And if all they ask you to do is make partial fractions, expand this by using partial fractions, this would just be the answer. That's all you're looking to do. First 8, that's what the directions say. Just do this partial fractions trick and turn one bigger fraction into two littler fractions. When you turn the homework page into number 9, they'll start asking you to do integrals. So if I rework this problem so that it looked like this, what we'd be looking to do are the integrals of both of those. And we have an extra step here at the end. Most fraction integrals are ln's. It's either ln's or we have like those inverse trig ones, but it's usually ln's. They're ln integrals if the bottom's derivative is on the top. The derivative of this is 1. We have a 2 on the top, so we can just kind of ignore that 2, and it would be the ln of the bottom. And this is also an ln integral because the derivative of the bottom is 1, which the top is more than enough. There's a 3 that we can just shove out of the way. And then there's an ln of the bottom plus a c. Second type that you have that you should keep an eye out for, anytime the top has a power that's bigger or matches the bottom, you're going to have to divide that. So if this 3 were a 2, we'd have to divide it. If 3 is bigger than 2, we have to divide it. If the bottom has a 2 and the top has anything, 2, 3, 4, 5 and up, we have to look to divide. You're not able to do this method if you have improper fractions. So this would go out of the box. This other top would go in the box. When we divide, we just divide the liters. So that's the 2x cubed. This has to multiply all three things. So minus a 4x squared, minus a 6x. Subtract eliminates again. Subtract makes this a plus, so 5x minus 3. We could rewrite this problem as this plus write the remainder as a fraction. This goes on top, the original bottom stays on the bottom. Then we'd focus on doing this the same way we did before. And the book was clever in how they wrote their examples. They wrote it so that example 2 explained how you have to long divide when the top is bigger, but they turned it into the exact same problem we just did a second ago. So if this were a homework problem, we would now have all those same steps to repeat that we just did, just with a 2x hanging out in front. And if we were doing the integral of that in the end, the integral of 2x would be an x squared. But we would look to long divide anytime there's an improper situation, but then the remainder will need to get broken down. So that's example 1, 2, 3. Okay, example 4 is the last example. We'll do 2 things with this. They're giving you 2 different things about this. Anytime the bottom has a power higher than just an x, so if we have an x squared plus 1, the top is maybe not only just having a number, but it could have a number and it could also have an xy kind of thing and still be proper. If the bottom has x squareds, the top could have x squared, or could have x's or numbers or both. So if we have a thing like x squared plus 1 on the bottom, on the top I'm going to put ax plus b, because there could be a mystery number of x's, there could be a mystery number of just plain old numbers on top of x squared. Second thing they're doing on this to illustrate 2 points in one problem. Anytime you have a factor that's squared, you're going to have to use it twice. So with x minus 1 being squared, we need an x minus 1 basic fraction bottom and an x minus 1 squared bottom on some other fraction. This I'd call C, this I'd call D, because they're mysteries to me. Then we do the same kind of thing we were doing before. We would try to multiply everything by the common denominator. By common denominator, I mean all of this stuff. So in this fraction, the top is left unchanged. For this fraction, the ax plus b would multiply this item. Because because this would get canceled. That's the extra thing. The C would have to multiply another x minus 1, because one of them got canceled, but the other one is still a foot. And then x squared plus 1 is in the mix. In D's world, this would get canceled, which would leave the x squared plus 1 still a foot. A lot of this homework's going to come down to like distributing, foiling, that kind of a thing. So let's do a little foiling here. If I square out x minus 1 squared, that's x squared minus 2x plus 1. If I FOIL this stuff, there's an x cubed minus an x squared plus an x minus a 1. This is going to need distributed. This C will need distributed. This is going to need refoiled. So let's go after this. This will go ax cubed minus 2ax squared plus an ax. If I multiply everything by this ax, that makes three things. The b has to multiply everything. Bx squared, 2bx, and b. The c has to distribute everything. And the d has to distribute. And if you're thinking, please don't tell me these problems are all this big, these problems are not all this big. This is the ginormous biggest that you're going to see anything go. Then we look to make some equations. The highest power of x's that I see is 3 of them. Here I have an a plus a c, and that would equal 0 because there are no x cubes over there. For x squareds, there's a negative 2a plus a b minus a c plus a d, and that also equals 0 because there's no x squareds over there. For the x's, there's an a minus a 2b plus a c, and that would equal a negative 2 because we did finally have some x's. And then for the thing without any variables, there's a b minus a c plus a d, and that would equal 4. And again, this is called a system of equations. There were 4 letters, so we got 4 equations. That's not how most of the homework will go. More of the homework will have 2 letters, 2 equations, like the one we did. This had 4 letters, 4 equations. What I would do is look for the 2 that to me most resemble each other. And there's 2 pairs that pop out to me. I'll number them 1, 2, 3, 4. 1 and 3 are almost a match because they both have a plus c's. So we can play equation 1 and 3 off of each other because if we would switch the signs of either of them, let me think about switching the signs of this one. If I switched all these signs of 3 and I add it to 1, the a's would eliminate. I'd have a positive 2b. The c's would eliminate, and I'd have a positive 2. In other words, b is 1. Back up here, I got a 1. 2 and 4 are also real similar to me. They have b's, they have minus c's, they have plus d's. So if I switch the signs on either 2 or 4, I could add them together and get some nice eliminations. So in my mind, I'm thinking about switching the signs on 2. So I get a positive 2a The B's eliminate, the C's eliminate, the D's eliminate, and when I put these together, I get a 4, telling me that A is 2. So I go up here, and I have a 2. Then I look back through the system and think, well, now that I know B and A, is there anywhere that doesn't look too bad to get another letter? Well, this one doesn't look bad at all. Now that I know that the A is a 2, the C must be -2 for this equation to work out. So my C is -2. And then I need some kind of a problem to get me D. This looks like the easiest problem that has a D in it. So I need to grab a B, which is 1, minus a C, which was -2. So minus minus 2 is add 2. I'm up to 3. For 3 to add B and get 4, the D must be a 1. And I'm good with that. The example 5 in the book, it's the same problem, they just ask you to do the integration step. So doing the integral on this, take a step to an empty space over here on the left. For me to do the integral of those 3 pieces, the first piece I would make into 2 pieces. I'd have a 2x on top of the bottom, plus a 1 on top of the same bottom, minus, there's a 2 on top of this. So if we're going to go to do those 4 integrals, this one's an ln integral, because the bottom's derivative is on the top. So that's the ln of x squared plus 1. I don't need any bars, because I'm sure that that's positive. This is also an ln integral. The derivative of the bottom is on the top. The derivative of this is 1. I just need to scoot the -2 out of the way. This is on our card. That is inverse tan of x. Those fraction integrals, if they're not ln's, they're usually inverse trig things. And then this integral is a pick a u kind of integral because it doesn't fit any of the formats. U would be x plus 1. Du would be 1. So that integral has a u to the -2. So when we do that, we raise the power up to be u to the -1. Divide in front by the -1, and then reinsert the u. Instead of -1 power, they'd probably go back to fraction and just put that on the bottom, one of them, and a plus c. And again, most of the homework is not that nuts. There's a box on 527 that sort of explains the rules, not a box, it's just sort of here in the margin, that if you have a normal factoring on the bottom, your tops are just an a and a b, each having a factor. If you have a top on top of a square, you make 2 fractions, an a and a b, 1 square on the bottom and 1 regular item on the bottom. And then they also showed you one that sort of fit the format like that last one, but there's 3 options. But keep your eyes peeled for it. The top has a higher power along divide, but other than that, the problems should be kind of like the ones that I did, but not mostly as hard as that one. We're on 527, doing odds and evens today. One other thing that does come up in the homework, sometimes when they factor, you might just get like an x. If you just got an x, we would on the bottoms have done like just an x. If you had an x squared, you would do an x in one and an x squared in another. But you treat these plain x's kind of like you would treat the parentheses groups. They can each take ownership of the bottom. See ya.